Good evening, everyone. This is our February Speakers Night for 2023. Hope you've all gotten good views of anything you've been out there looking for, but especially the planet Mars. Welcome to Rask Toronto Centre. So, this is, as I said, February. That means that we are online tonight, and I'm here to help present the February Speakers Night. I am Dr. Elena Hyde, the second Vice President of Rask Toronto Centre, and this is our February Speakers Night just getting started. This is one of two types of gatherings we have online these days, not at the Ontario Science Centre due to the pandemic. Later on tonight, our President Tom Luton will be talking about our various programs. But first, we have, of course, a very special event to get kicked off. And before we get started, I want to take a moment just to acknowledge that the Royal Astronomical Society of Canada Toronto Centre meets on the traditional territories of many Indigenous nations. This includes the Haudenosaunee Confederacy, the Huron-Wendat, the Mississaugas of the Credit First Nation, and other Anishinaabe peoples. Those lands are part of the Dish with One Spoon Treaty and are now home to many diverse First Nations, Inuit, Métis, and Indigenous people from around Turtle Island. As we engage in astronomy here tonight, together, we respect, learn from, and honor the deep relationship between Indigenous peoples, the sky, and the earth. Now, without any further ado, I'd like to go ahead and get started introducing our fantastic speaker for this evening. Alex Innanen, Master of Science and a PhD candidate at York University, is studying planetary science. They primarily study Mars's atmosphere, and their master's work focused on Martian cloud properties and interactions over on Mars between the atmosphere and the poles. So, if you've ever been, as they say, curious or curiosity, if you will, about our red neighbor, Alex is the perfect person to tell us all about it. In fact, I'd say this is actually the perfect talk for February since our red neighbor is well known for its abundance of red heart shaped craters and, well, slightly less red, more brown heart shaped craters as well. So, everybody, happy recent heart shaped crater day if you are listening, in fact, live. It was yesterday, February 14th. Tonight, we are going to learn more than just about the surface of Mars, I suspect. As for their PhD, our speaker Alex has actually been helping to develop an instrument, which I'm thinking we'll probably hear a little bit about tonight, that will study the origin and evolution of mysterious Martian methane. So this is a very, very cool topic, but our speaker will tell us all about it, I'm sure. Alex is also a part of that same Curiosity rover's environmental science team. That's right, part of the official science team. So you're hearing it here from the authority. taking part in rover science operations planning. So, just as a little call out to anybody who is watching this live, if you're out tonight in Toronto and you happen to have clear skies, Mars is actually up. So Mars rose around 11:33 a.m. today and it will be setting around 3:14 a.m. So lots of Mars viewing opportunities out in the sky if you feel particularly inspired by this evening, and of course, weather allowing. So, if you are looking forward to the opportunity for some insight, I'd like to thank you for your perseverance and listening to this rather long introduction. And I'll say, without any further ado, Alex, please take it and us up, up, and away.
Thank you, Elena. I'm very excited to talk to you all tonight about Curiosity's past 10 plus years on Mars. Um, so, Curiosity landed in August of 2012, and since then has been exploring the red planet, and I will get into that. But first, I called this section of the show "Over Explaining My Title." So this was a very beautiful poster that the team at JPL put out for Curiosity's 10th anniversary. Um, I especially love it because it shows the geology that Curiosity does, but it also shows some of the atmospheric science. So you can see those nice wispy clouds in the back, and I'll have more pictures of actual clouds later. But what I also like is the little catchphrase that they have on it: "Stay curious." And I think Curiosity is a perfect name for this rover, because when we're exploring space and when we're exploring Mars, we're doing it because we're curious. We want to know what's out there. So it's 10 years of Curiosity the rover, but also 10 years of us asking questions and being curious about Mars. So before I get too far into things, there are some terms that I'm going to define, and this is just a selection, but a so first of all, a sol is a Martian day, slightly longer than an Earth day, and we count mission time by sols. So sol 0 is landing, and then we count up from there, and we're at about sol 3744 right now. Um, so we've been on Mars a while. Next, MSL is the Mars Science Laboratory, which is also known more commonly as Curiosity. So if I say MSL, that's what I mean. Really, space is all about three-letter acronyms. So lots of those tend to come up. Gale Crater is where Curiosity is. I will talk more about why it's such an exciting place for Curiosity to be, but it's about 5 degrees south of the equator. Um, and right now it is actually the fall in Gale Crater. Um, and then finally, Mount Sharp, or Aeolus Mons, is this big mountain that you can see at the bottom of the slide here. Um, and it is another reason that makes Gale Crater such an interesting place to study. So I really like this graphic that the Planetary Society put out showing all of the current and past explorers on Mars. Um, there's quite a big family, but Curiosity is right here. And you can see pointing to Gale really near the equator. So the question is, why was Gale Crater chosen to be the landing place for Curiosity? And there was actually a 5-year site selection process, and you can see some of um, the sites that made the short list of where Curiosity would land. And a lot of factors went into determining where to land, such as how easy it is to land there, what kind of interesting things could we look at there that we might have seen from space, and things like that. But eventually, Gale Crater was chosen. Um, and in the site selection process, they were really interested in answering some overarching science goals, which kind of boiled down to, was Mars ever habitable? And there are a few things you need for habitability, such as liquid water, organic compounds, some form of energy. Um, and Gale Crater looks like, from orbit, it looks like a place where there might have once been water. Um, so Gale Crater, we know now, is probably a lake bed, and it's got this mountain in the middle, Mount Sharp, that is formed from layers of sediments. So that's really interesting because the sediments build up over the years. So as you kind of climb up Mount Sharp, you're going up the layers of sediments and you're actually going from very far back in time to into the future. So you're almost time traveling as you're climbing up Mount Sharp, which is really cool. We can see different eras of Mars's evolution and understand maybe some of the processes that happened to Mars. So here is our Martian explorer. Um, one of the main um, tasks that Curiosity has is being a geologist. Um, And when geologists on Earth go out, they have lots and lots of tools with them. Curiosity had to take all of its tools, all of its stuff to do lab work, everything with it. So here is an overview of all the instruments. There are a lot. I highlighted APXS, which is the Canadian instrument. Um, that is the alpha particle X ray spectrometer, which explores the mineralogy, so the makeup of some of the rocks on Earth, and can also do some atmospheric analyses too. So the colors here, basically, blue are cameras, red are kind of engineering type instruments, and then the greens are more of the science type instruments. So just a couple to highlight, we have REMS, which is the rover environmental monitoring system. So that's actually a number of instruments that measure stuff like temperature, um, humidity, how much UV radiation is reaching the rover. Um, it was supposed to be able to measure wind. Unfortunately, shortly after landing, the wind sensor broke. Um, and the problem is that many years later, we sent Perseverance to Mars, and its wind sensor also broke. So we unfortunately don't have a ton of idea about what wind is doing on Mars. Um, but a couple of other um, important instruments or notable instruments, I guess, are ChemCam, which is the quote unquote eye. And it's the one, if you know something about Curiosity, you might know, oh, it has a laser that pulverizes rocks. So that's ChemCam. And it also can do chemical analysis of what the rocks are made out of. So Curiosity made its first drive towards the end of August, so almost a month after landing. This is not its first drive, but this is a view of Curiosity having made some drives from the HiRISE instrument, which I just think is such a cool image. You can see the tracks and you can see the tiny rover. So this is an orbiting camera that has a good enough resolution to actually see the rover on the surface. Um, but since its landing, Curiosity has traveled almost 30 kilometers. And it took its time kind of, so it landed in the flat basin of Gale Crater and it explored that, but it was mostly making its way towards the mountain to climb. So it took 2 Earth years, or about 1 Mars year, to make it to the base of the mountain. And ever since then, it's been climbing up the mountain. And as I said earlier, as we climb and get to different layers, we can see different past evidence of different past processes. And this is the first picture that Curiosity took right after landing. So it's using its hazard camera. So it has hazard cameras at the front and the back that kind of can keep an eye out for anything that might be um, near the rover, but can also take really nice pictures. Well, maybe not really nice, but it can take cool pictures like this one of Mount Sharp, um, looking towards where we were heading right after landing. Um, so as I said, Curiosity was looking for evidence that Mars would have been able to support past life. Um, So things like evidence of past water, but also things um, like organic molecules and or molecules that are needed for life. And actually, on its first drill, um, uh, in 2013, it found evidence of of both water and other molecules that were needed for life. So fairly easily, Curiosity was able to say, "Oh yeah, it was possible that in the past Mars could have supported life," which is really, it seems almost obvious now, but it's a really cool finding. Um, this is kind another fun image of looking towards Mount Sharp and all of the hills and buttes that we've kind of now traveled through. So this is from about 1,000 sols into the mission. Um, and I've circled, you can barely see it. It's a little tiny speck. Um, and recently, last summer, we passed that speck, and it's this big boulder. Um, I think that really goes to show how far we've traveled. It maybe doesn't seem like as much when you're looking at all of Mars, but when you look at that picture, that tiny speck turns into a whole rock. Something else to notice about that picture on the last slide was that it had like a blue sky. Um, Mars doesn't really have a blue sky. So when pictures are taken on the rover, there's different processing that can be done to them. So the middle picture here, the quote unquote natural color, that is what you would see if you were standing on the surface of Mars. So you can see the aptly named red planet, and you can see this kind of tanny, orangey sky. And that's what you would see if you were on the surface of Mars. And then the one on the end, the white balanced, that's that picture that I showed earlier with the blue sky. That's the kind of processing that's done to that. So the reason that pictures that processing is done to pictures is that it makes rocks and features in the pictures look similar to how they would look under Earth-like lighting conditions. And why that is useful is because geologists can then look at a rock and say, "Oh, that looks like something that I'm familiar with on Earth," and it's much easier to make those kinds of comparisons than in the Mars lighting condition. And there are lots of things that we've seen on Mars that are similar to things we see on Earth, which is really cool. So going back to this question of was Mars ever habitable? So I said we found evidence of molecules that can support life. Another thing we're looking for is was there liquid water on the surface of Mars at any point? So currently on Mars, there is frozen water. There's water frozen in ice, primarily at the polar caps, the north and south polar caps. And then there's a very, very, very little bit of water vapor in the atmosphere. Um, and there's currently Mars cannot support liquid water on its surface because the pressure is so low that solid ice water turns directly into water vapor. Um, but could there have been liquid water on the surface in the past? And the answer is probably yes. So I love this comparison picture. It shows evidence of past flowing water in Gale Crater. So you can see these round, smooth pebbles. And the on Mars versus on Earth, they look so similar, like something you would find in any stream bed on Earth. So this is really good evidence that there was once water flowing on Mars because that's something that can make these kinds of pebbles. Other evidence is this is what's called mudstone. So basically, as like a hydrated, like a mud or something, as the water evaporates and it can solidify into stone. And there are some rocks on Mars as well that actually have water molecules bound into the minerals themselves. And we found these. these minerals that are bound up with water molecules. So it's other good evidence that there once was liquid water on Mars. And in fact, I mentioned this earlier, but Gale Crater was probably once a lake, and it was actually probably a freshwater lake. Um, I like this picture that Kevin Gill did. It's a kind of mock-up of what that lake in Gale Crater might look like. Um, and it looks like, well, it's very red, but it looks like any old crater lake. Um, and it's fun to think about. Um, we might have traveled over areas that were once deep underwater. So another way to analyze the composition of rocks for things such as molecules needed for life and these kinds of things is by drilling. So as I showed in the picture of the rover, Curiosity has a drill, um, and we take uh, fairly often we take drill samples um, of the various rocks that we're encountering. So these are the 36 drill holes to date. There is a caveat on that, but out of all of I will get to that later. Out of all of these samples or these drill holes, we've been able to collect samples, and those are analyzed within. So Curiosity has, aside from APXS and ChemCam, which I talked about earlier, it also has two internal like mini laboratories, and one of those is SAM, which is the sample analysis at Mars. And the other one is ChemIn, which is the chemical and mineralogy suite. And both of those are kind of like mass spectrometers that can analyze what the makeup of these samples are. I really like seeing all these drill holes together too, because you can see the various different colors of the rocks. Um, so the the kind of redder rocks are more oxidized. Um, so they're potentially being in contact with the atmosphere more. And the grayer rocks are less oxidized, and those are actually the ones that are better for finding um, these molecules that could be used for life in them because they haven't had as much contact with the atmosphere and degraded and things. Um, so that was kind of the geology side of the rover. But the other near and dear to my heart part of the rover is looking at the atmosphere and the environment of Mars. Um, so this is maybe my favorite picture of Mars or that Curiosity has taken. This is um, a feature, a cliff face called Montmarcou, or the Montmarcou cliff face, and it is 7 meters tall, if you can picture that. So at one point, the rover drove up to Montmarcou and took a lot. We drilled there. We took a selfie there. Took a lot of measurements. We even kind of nestled the rover right in close to see if the rock or if cliff faces such as these could potentially shield the rover, or if there were people there from radiation a bit. So when we do send astronauts to Mars, could being near cliff faces um, help them get out of the like intense radiation on Mars. But also at the time that we were at this cliff, it was twilight cloud season, which I will talk about more in a bit. And we got these gorgeous clouds, and you can see them here. They're kind of iridescent. They look like they're glowing because of how they're illuminated by the sun, and they're thin, wispy little clouds. And this picture, I love it because it's beautiful, but it also shows, the atmospheric side and the geology side. Um, so more on the atmospheric side, we monitor things like the weather, so temperature, humidity, those kinds of things. But we also look at other kind of more transient events. So we look at clouds. So yes, Mars has clouds. Um, Mars has both carbon dioxide clouds and water ice clouds. These that you can see on the slide are probably water ice clouds. Um, so so are formed of water ice crystals. So if you are familiar with cirrus clouds on Earth, those kind of wispy like mare's tails or whatever, those are made of crystals of water ice as opposed to water droplets. Um, so that's some of the clouds that we see on Mars are also those kind of water crystals. Um, and they're very, very, very thin. And this image is actually enhanced. So we do some post processing once we get the images down to be able to pull out these features. Because if you were looking at the raw images, you might not be able to see anything in them. And then another cool thing that we see on Mars are dust devils. Mars is very, very dusty. There's lots of fine grained um, dust or sand on the surface, and that dust gets lifted. I'll talk about another aspect of that just in another slide, but it also can form these kind of twisters of dust. Um, and so we keep an eye out for them too, especially when we're around places that have like a sand dune or something like that, where there will be good dust lifting. So the other thing that dust does is it forms dust storms. So one of the really cool things that Curiosity was on the surface for was the global dust storm of Mars Year 34 or 2018 here on Earth. Um, And what happens in a global dust storm, you can kind of see that animation in the bottom. The dust storm or multiple dust storms grow and they grow together, and eventually the dust entirely encircles the planet. It's just like an unbelievable scale. We don't really have anything like that on Earth, and Curiosity was right in Gale Crater when it was happening. Unfortunately, Opportunity was also on the surface. Um, its solar panels got covered in dust most likely, and we lost contact with it. So that was a bit sad, but it was great that Curiosity was able to observe the whole storm, get a ton of science out of it, and get this really cool um, GIF that's kind of in the top of this slide, where you can see just the dust. We didn't move at all in this. We're facing the exact same way, and you can see the crater rim completely disappear because of all the dust in the atmosphere. So Curiosity is still going strong. We're actually in the fourth extended mission of its time on Mars. Um, space missions will have kind of a primary mission. With Curiosity, that was 1 Mars year or 2 Earth years, and then they get as funding is available and as the rover or the spacecraft is still able to go, they get extended. So we're in the fourth extended mission right now, which is very exciting. Um, and we're still climbing up the mountain. This is a fairly recent panorama of the where we are right now, and you can see like all of the buttes around us. We're kind of in a valley right now. What was exciting recently is we reached this salty region or sulfate region. Um, so down on the floor of the crater, and kind of at the bottom of the mountain, a lot of the rocks were clay bearing. So those are rocks and minerals and things that are left behind when there's a lot of water. But as we go into the salty region, we reach rocks that maybe formed when the climate was drier, when it was drying out. Um, and there's been lots of sulfates and things in, so like magnesium sulfate, calcium sulfate, if that means anything to anyone, in the minerals um, that formed as the climate was drying out and kind of becoming this drier Mars that we see now. The other uh, thing that we're exploring right now is what's known as the marker band. And this is a feature that you can actually see from space. So this is satellite imagery that's put together, and the marker band is this dark kind of almost a ridge, and we are right on top of it right now. Um, and it's an interesting feature, partly to do with how how the mountain was formed, and what the kind of chronology of the formation of Gale Crater was. So we have been trying to drill it recently, and here are two drill attempts that have been made in the past few months. Unfortunately, the marker band is very hard, which is part of the reason that it's persisted and that you can see it so clearly from space. So there is another attempt ongoing, and yeah, hopefully there's been lots of other analyses that have been done at the marker band as we've been kind of driving up and down across it. So it's not a complete wash, but we keep trying to drill it to see what it's all about. The other thing that's happening right now that is very exciting for me is that we are once again in twilight cloud season. So that beautiful picture of Montmartre showed twilight clouds, and this is a gift that I put together of some twilight clouds that we saw very recently. Um, so only about a week or so ago. Um, and these images, you can see the still images on the Curiosity raw image site, which I have a link to at the end. But what twilight clouds, or as they're also called noctilucent clouds, which means night illuminated, and what these are very high clouds in the atmosphere that are actually illuminated after the sun sets. So the sun has set beneath the local horizon, but because these clouds are so high, it's actually shining on the clouds, and that's what makes them almost appear to glow. Um, and they're so beautiful. You can see them in the raw frames. It's not like the other clouds I showed that we have to do image processing to. Um, and you can these are a couple pictures that are images that we took last twilight cloud season, and you can tell a lot about the properties of these clouds. Um, so on the top, you can see the clouds moving and the sun setting on the clouds. So the shadow kind of moves across the clouds. And if you know the time that they're taken, which we do, and if you know where the sun is, so its elevation below the horizon, then you can actually use like trigonometry to figure out exactly how high these clouds are, which is really important because Curiosity doesn't have um, any kind of instrument that can directly measure how high clouds are. The other thing that we can use twilight clouds to know about is if we take an image in color, we can actually, so the bottom there, that's a stretched color image. So that's not what the clouds would look like if you were looking at them. The colors are kind of enhanced. But based on the different colors and where they show up in the clouds, you can tell things like particle size and potentially um, what kinds of particles the clouds are made out of. So these could be carbon dioxide clouds as opposed to water ice clouds, which would also be really cool because often carbon dioxide clouds are more around the North and the South Pole, and we're right near the equator. So, as I said, Curiosity monitors the weather. So, we're going to play a game right now called Is It Colder in Toronto or on Gale Crater? Obviously today, I think it got up to 13 degrees or something. It was not colder in Gale Crater. And as I said earlier, we're in the fall right now on Gale, moving into the winter. So we are seeing slightly lower temperatures, but I went back in time about a week ago when we had that really, really cold day. And it turns out on February 3rd, it was the same temperature in Toronto as in Gale Crater on Mars. Um, yeah, this this is a game I like to play, especially in the winter. Um, it's really interesting, the differences in high and low temperature on Mars, and that is due mostly, or a lot to the thinness of the atmosphere. So in the day when there's sunlight, it can get warmer, um, and at nighttime, when the sun's gone, the heat just kind of gets sucked right out. Um, but the other interesting thing is that the ground retains heat a lot easier. So if you're standing on Mars, your feet could actually be warmer than your head. So that is the end of um, my prepared remarks. I'm very happy to take questions, but I also put together a list of links to do with MSL. So there are things like the raw images and also link to the blog posts that we put out every planning day, and some other just like fun, exciting links about curiosity. So thank you so much for listening, and really excited to hear any questions anyone has.
Well, thank you so much, Alex. It's been absolutely awesome. I hope we all can agree that the images and the curiosity that you've inspired in all of us is quite remarkable. And I have to admit that that hill you showed us, the Ilha Novo Destino, I'm quite willing to believe that actually is in the shape of an upside down heart. So it was very fun, and we could probably talk about this quite a lot. But I think there are a few questions over from chat, so I'm going to take this opportunity to pass you over to Emma, who will look for any questions from YouTube coming your way. So go ahead, Emma.
Thank you. This first question is there a reason the wind sensing instruments are more vulnerable to failure, or is it by chance that they broke twice?
Um, so yeah, the one on curiosity, I'm going to be honest, I'm not entirely sure what all of the problems in with it was. You can kind of see if you look at like a closer up image, it's like a thing that sticks out of the neck of curiosity. And so the problem with perseverance um, was that it got hit by a rock and it broke. Um, but they actually learned after the Curiosity one broke, and they made changes to the Perseverance wind sensor. But then it broke again. I think kind of it's luck of the draw. It is unfortunate. Um, my This is a bit off topic, but my favorite wind sensor that has been sent to Mars was on the Phoenix lander, and it was basically just a piece of Teflon tape that dangled, and then they took pictures of it, and you could see which way the wind was blowing.
That's funny. Great, thank you. The next question is what could the wind have told us, and what gaps exist now in our knowledge because we don't have that wind data?
So it can tell you things like I don't know, prevailing winds, where dust transport is likely to go, things like this. Um, there have been attempts to, I guess, indirectly derive some of those things. So, like if we look at clouds, you can see the direction that clouds are going. So then you can get kind of the wind direction aloft, and you can get indirect wind speed based on like how quickly the clouds are moving, and things like that. Um, the other reason that wind in general is important to the climate is it helps climate modelers, so people who are making models of how processes are going on Mars, because there's a lot of let's call it educated guesswork, and as there's more data, like actual observed data from Mars, that can then be fed back into those climate models to make them better, to then help um, things like future missions, understand what's interesting to look at, or even things that might affect the mission, like dust storms, for instance. If you have solar panels, you're very vulnerable to dust storms.
Yeah. Um, cool. This next question, how would something like a saltwater lake differ in terms of evidence?
That's a really good question. um, I should have said at the beginning I am not a geologist. So this is maybe a slightly educated guess. I assume maybe we would see more of those kind of sulfate minerals um, in evidence, like in the crater floor itself. I Yeah, that's a really good question that I'm very sorry I don't have a better answer to.
Well, that's all right. We'll just move on. The next question, does curiosity keep the soil samples or discard them after its analysis?
They're discarded, yeah. It's not like with Perseverance where they're cached or anything to eventually go back to Earth. They're just kind of after they're analyzed, they're dumped so that there's room for more samples, especially after like 10 years. It would be a lot of dirt to be hauling around.
Yeah, that's very true. That's all the questions we got. You did actually get a comment though that it was colder here in Ottawa on February 3rd than on Mars.
Yes.
So
I do have family in Ottawa that were telling me. I was like, "Oh gosh."
Thank you again, Alex. It's been great having you on the show. I think we could stay here quite a while, perhaps looking for our next best place to put any future Mars houses we might want to build. But we do have to round off the evening here. So I love the images of the clouds you showed us and the differences between the water ice and the CO clouds on Mars. So it's been a great pleasure having you on. Thank you very, very much once again. And with that, let's go ahead and hand over to the president of the Toronto Centre, RASC, Tom Luton, to finish off the evening.
All right, and thank you very much, Elena. So, good evening, everyone. I'd like to thank Alex Innanen, our wonderful speaker, for a wonderful talk. Before we get into the announcements, I'd like to give you guys a little bit of an update what's going on. We'll be giving you a fuller picture of this in the next day or so. But just so you know, the National Society had a bad fiscal year last year to the extent that they've implemented some cost cutting measures. One of which was announced today that Sky News, effective immediately, is being shut down. We're going to be giving you the full details, we're going to be giving you fuller details in the next day or so on the forum. But just wanted to let you guys know that what's going on. And with that, I'm going to bring you the announcements. So, as Elena was saying, we've got two types of meetings here with the Toronto Centre. We have our recreational astronomy nights and we have our speakers nights. If you're watching us live, please use the YouTube chat, say hello, enter some questions for the presenters. If you're a new member, please introduce yourself. And if you're coming to us from far, far away, please let us know where you're coming from. So our next recreational astronomy night, which is going to be both live at the Science Center and online, will be on the 1st of March, 7:30 p.m. Claudio Oriani will be discussing the sky this month, and we currently have 2 open slots. So if you'd like to present something, please contact Paul Markov. And then our next speakers night will be on Wednesday, the 15th of March at 7:30 p.m. That will be online only. Parisa Nazari of Queen's University will be discussing From Dust Grains to Stars and Shots in the Dark, online at youtube.com/rasktoronto/live. Coming up to the DDO in the next little while, on Saturday, February 25th at 7:30 p.m., is DDO Up in the Sky. And Sunday Sun Gazing on Sunday, February 26th at 12:30 p.m. You can register for all these events online, and the links are to be found at raskto.ca. A little bit more bad news. We have been trying for the last several weeks and months to clarify the parking situation with the town of Blue Mountain um, with respect to our observatory. As you may or may not be aware, the last kilometer of the road is not plowed in the winter. Over the years, we've had various arrangements for parking, and you trek in for the last kilometer. Those have all gone by the wayside. We've tried to arrange something new, and that's fallen through. And as a result, effective until the road reopens sometime likely in April, effective as of now, the CAO is closed. Sorry about this. It should only be, hopefully, something in the order of 6 to 8 weeks until the road reopens after the snow melts. So we're looking for a few folks to help out with the RAS Toronto Center. We're still looking for an education and public outreach chair, a light pollution committee chair, and a volunteer committee chair, and a marketing committee chair and some committee members. EPO is always looking for online presenters and as well for telescope camera operators for virtual star parties. Just a reminder that if you'd like to volunteer, you first have to be a member. If you haven't renewed your membership in a while, or if you like what you see and you'd like to join the Royal Astronomical Society of Canada, you can do so online at secure.rask.ca. Gift memberships are also available. You can contact the national office at mempub@rask.ca. And with that, I'd like to wish you all a pleasant evening. Thank you very much for joining us. Please follow us on all the forms of social media we've got listed here. If you like what you see here on YouTube, please like and subscribe and hit the notification bell. Be safe. Keep looking up. Good night, everyone.